Welcome everyone. We are discussing inverse circular function. I have already taken 3 basic classes to this chapter. Today I will discuss some board's problem using this theory. Sin inverse x plus cos inverse x equals to pi by 2. So this restriction should be noted. X lies between minus 1 to plus 1. Tan inverse x plus cot inverse x equals to pi by 2. X belongs to minus infinity to plus infinity. That is domain of tan inverse x plus cot inverse x, sin inverse x, cos inverse x. Sec inverse x plus cosec inverse x equals to pi by 2, x greater than equals to 1. That is, x does not lie in between minus 1 to plus 1. So, restriction. So, these are actually domain of this function, sin inverse x plus cos inverse x. Now look, sin inverse 2 plus cot inverse 2, cos inverse 2 equals to pi by 2. So, this is x, this is x. It is same, but it is not pi by 2. Because here x equals to what? 2. So, this is not the domain of sin inverse x plus cos inverse x. Next look, these are basic things. Sec inverse 1 by 3, this is not defined. Cosec inverse 1 by 3, it is not defined. So, sec inverse x plus cosec inverse 1 by 3 equals to pi by 2, this is also not true because they are not defined. And you know, tan and cot, tan inverse and cot inverse. So, domain is minus infinity to plus infinity. So, tan inverse 2000 plus cot inverse 2000 equals to pi by 2. This is correct. So, you should remember the restriction on this theorem. Next, 1 mark problem for board. So, evaluate cot tan inverse A plus cot inverse A. Evaluate. Now, tan inverse A can take any value. That is why no restriction is given on A. So, this is cot. And by well-known theorem, tan inverse A plus cot inverse A. This is pi by 2. So, this equals to 0. So, tan inverse A plus cot inverse A equals to cot pi by 2 equals to 0. Now, look, sin tan inverse 3 plus cot inverse 3. So, 3, x can take any value. This is sin pi by 2. Sin pi by 2 equals to 1. Next, sin sec inverse 5 plus cosec inverse 5. So, x equals to 5 greater than 1, so it is defined. Now, sec inverse plus cosec inverse. This is again pi by 2, so sin pi by 2 is 1. So, these are only 1 mark problem or MCQ type of problem, but most important for board's problem. Now, I will consider again 4 simple problems. So, these are of 1 marks using this theory. Solve x. Sin cos inverse 5 by 3 plus sin inverse x equals to 1. So, consider problem number 1. So, sin. So, what is right hand side? Right hand side is 1. So, you know, if sin is transferred to right hand side, so it will be sin inverse. So, this implies cos inverse 5 by 13 plus sin inverse x equals to sin inverse 1. Sin inverse 1. So, we take the principal value. What is sin inverse 1? So, So this is pi by 2. This is pi by 2. Now our unknown variable is x. So sin inverse x equals to pi by 2 minus cos inverse pi by 2. Now from theory number 1, sin inverse x equals to pi by 2 minus cos inverse x. So pi by 2 minus cos inverse x is sin inverse x. So sin inverse x equals to this. So x equals to 5 by 13. 5 by 13. So only 1 mark problem. Next, second one. Second one is exactly same. So leave it. You complete it. Now problem number 3. Cos exactly same, but here it is cos. Cos sin inverse 2 by 5 plus cos inverse x equals to 0. So transfer cos to right hand side. This implies sin inverse 2 by 5 plus cos inverse x equals to cos inverse 0. So sin inverse 2 by 5 plus cos inverse x equals to pi by 2. So we are taking principal value. Cos inverse 0 is cos inverse cos pi by 2. Now unknown is x. So cos inverse x pi by 2 minus sin inverse 2 by 5 equals to cos inverse 2 by 5. So what is x? X equals to 2 by 5. X equals to 2 by 5. So we are getting answer as x equals to 2 by 5. So transfer cos to right hand side. So cos inverse take 0, take principal value and solve. Next, so problem number 4. 5 tan inverse x plus 3 cot inverse x equals to 2 pi. So look, we try to make it in terms of single trigonometric ratios. So what is cot inverse x? 3 by 2. 3 into pi by 2 minus tan inverse x. Tan inverse x equals to 2 pi. Now 5 minus 3 equals to 2 tan inverse x. So 2 pi minus 3 pi by 2 equals to pi by 2. So what is tan inverse x? Pi by 4. So what is x? Tan pi by 4. This equals to 1. So very simple. Try to make it in terms of single trigonometric ratios. Then solve. So these are only 1 mark problem. Next. Now I can consider some problems. So this is 1 marks. Cos inverse x plus cos inverse y equals to pi by 4. Find sin inverse x plus sin inverse y. So this is very simple. You complete it. So cos inverse x equals to pi by 2 minus sin inverse x. And this cos inverse y equals to pi by 2 minus sin inverse y equals to pi by 2. Then you find sin inverse x plus sin inverse y. So this is very simple. Now 6 and 7. Problem number 6. Find x and y. Find x and y. So look, sin inverse x plus sin inverse y equals to pi by 3. So call it 1. So two unknowns, x and y, that is why two equations are given. Now cos inverse x plus cos inverse y equals to pi by 6. So pi by 2 minus sin inverse. So you correct it, this will be minus this one. So cos inverse x minus cos inverse y. So this is pi by 2 minus sin inverse y equals to pi by 6. Now pi by 2 cancel. So sin inverse y minus sin inverse x equals to pi by 6. So this is 2. So look, it is in terms of sin inverse x, it is also in terms of sin inverse x. So it is very easy to find x. So look, if we add 1 and 2, 1 plus 2 implies, so sin inverse x is cancelled out. 2 sin inverse y equals to pi by 3 plus pi by 6. So this is pi by 3. So sin inverse y equals to pi by